All right, hello, Matthew. So after doing the last video on Edpuzzle, when I looked at the data from the Edpuzzle, I saw a lot of people did a really good job with the algebraic problems, like the circle degree measures, but we struggled with the vocabulary a little bit. You need to make sure you go back and really review this vocabulary because it is crucial down the line. For the rest of the chapter. Okay, so just a reminder, a chord is a segment whose endpoints are on the circle. A tangent is a line, segment, or ray that intersects a circle at one point, and a secant is a line that goes through the circle twice, right? So you really need to go back and look at this. In addition, we should already know what a radius is, and we should already know what a diameter is. And we should be able to distinguish the difference between a radius, a diameter, a secant, tangent, and chord. Okay, so if you did not write these definitions down, it's a good time to basically go and do that. So in today's notes, right, we're going to add to this and talk about some properties of a tangent line. Okay, so we're actually going to go to GeoGebra and kind of work with this to show you. So first thing we're going to do is construct a circle and basically plot 2 points and construct tangent lines to the circle. And then we're going to have the tangent lines intersect outside the circle. And then we're going to end up drawing a radius in to see what happens here. Okay, so when I draw a circle, right, what I'm going to do is take this circle and I'm going to make sure I have 2 points drawn on this circle. So I got one and then B is another one. Now, what's nice about GeoGebra, it gives us the ability to just create tangent lines. So I want to be tangent to the circle at this point, right? And tangent to the circle there. Then this one, tangent at the point B, all right, and to the circle. Now notice, these two tangent lines intersect outside the circle. And what I'm going to do is I'm going to mark that intersection point. Now, one property in geometry that we see with this diagram is what I'm going to do is measure the length of segment CD and the length of segment BD. And what do you know here? You should notice that when we talk about this, I guess I'll go back and hide the lines. When I hide the lines and create the segments, what they're basically saying is the segment from the point of tangency to the intersection, point of tangency to the intersection is always going to be congruent. All right. So in this diagram, if two tangents intersect outside the circle, the distance from point A to B is equal to the distance from C to B. Okay. So the first theorem that we're going to talk about is if two tangents intersect outside the circle, then the distance from the point of tangency to the intersection are equal. Okay, so that's one thing. Now the next part, they want us to draw a radius from the center to the point of tangency. So if I go up here and I construct a radius from the center to the point of tangency, what do we notice here? Well, we know all radii are congruent. So even if I draw this in, I know radii are congruent. That has nothing to do with this. But what's interesting is, right, if I go ahead and measure this angle, what do I notice? That's 90 degrees. And if I look here, that is 90 degrees. So basically, when I look at this, if a radius and tangent intersect on the circle, a right angle is formed at the intersection. Okay, so this is two properties of circles that deal with tangents that we need to be aware of. Okay, so let's take a look at some examples here and see why this is important. When we look at a line, sometimes we won't know if it's tangent to the circle or not. Right, so we use the properties we kind of just talked about to really, help us determine if they are tangent or are not. So right here, if I look at this, we want to know, is line LM tangent to the circle at point L? Well, here's the thing. If I look at this, NL is a radius, and this is my tangent line. If this line is, or if this segment is tangent to the circle here, right, this should be a right angle. How could we test to see if it's a right angle? Well, if I know three sides of a triangle, right, I can use Pythagorean theorem to determine that. So if I take the two legs, right, so if I take 7 squared plus 24 squared, will that equal 25 squared? Well, this right away is 625. That's going to be 625. And since 625 equals 625, that means that this is a right triangle. And the two smaller sides always make up the legs, and the legs always make up the right angle. Therefore, LM is tangent to circle N at point L. Okay? So keep that in mind. All right, example 2. How can we find X here? Everybody's going to want to draw a segment from O to M, but that really doesn't do us any good. Think about what properties we just discovered, right? If I have a radius and a tangent line, right away, anytime I see that, I'm going to mark right angles here. Now, if I look here, right, if I look at this, I notice that this here is a quadrilateral, meaning a four-sided figure. What do all four angles in a quadrilateral add up to? They all add up to 360. So right away, all I have to do is take 360, subtract 117, subtract 90, and when I go ahead and subtract that, you get 63 degrees. So X is 63 degrees. All right. Now, this one is one of the ones where if you get it, you get it. If you don't, you don't, right? I'm not going to be overly concerned a lot with this. It's just understanding properties of circles and tangents, okay? It says a dirt bike chain is fits tightly around two gears. So these two circles represent the gears, all right? The chain and gears form a figure like the one at the right. Find the distance between the center of the gears. So what they're looking for is how far is it from here to here. Okay, now where this gets really difficult is you actually have to draw a specific segment in. Okay, now how would I approach this? Well, they give me the length of the radius here, and they give me the length of the radius here. What I'm going to do to figure out the distance from one center to the other is I'm going to draw another line, right, parallel to this line, right? Because when I do that, what figure is formed, right? A rectangle. What properties of a rectangle do we know we can use? If this is 2.4, I know this piece is 2.4. If this piece is 26.5, I know this piece is 26.5. So now, right, if I know this is a right angle, can I now use this right triangle to find that distance? Right away, I got to find this piece here. Well, if the whole radius is 9.3 and this piece is 2.4, 9.3 minus 2.4 will give me 6.9. So now, in this right triangle, right, the length I'm looking for is a hypotenuse. I'm going to go ahead and use Pythagorean theorem. 6.9 squared plus 26.5 squared equals the hypotenuse squared. So 6.9 squared plus 26.5 squared gives you 749.86. And when I take the square root of that, you get about 27.4 inches long. Okay? Again, this is a very difficult problem. And if you understand this, it's awesome. Okay? If you don't, totally understand. Example 4, though, this is different. Okay? So we have to be able to do this. So right away here, I need to find the perimeter of this outside triangle. So what we say is we say the circle is inscribed in this triangle. Well, if I look here, anytime you see problems like this, you have to know that if the line appears to be tangent to the circle, it is. So all of these lines are tangent to the circle. All right. Now remember, what did we just say? When two tangents intersect outside the circle, right? What do we know about those segments? Well, I can tell you right now that that segment's congruent to that segment, this segment's congruent to this segment, and this segment's congruent to this segment, right? Because from the point of tangency to the intersection point will be equal to the point of tangency to the intersection, okay? So with that in mind, if this segment's 10, what does this have to be? Well, this has to be 10. If that's 15, what is this going to be? 15. So now the perimeter is just going to be 10 plus 15 plus 15 plus, what is this segment? 8 plus 8 plus another 10. And when I add these all up, right, what is that? 50 plus 16 is, the perimeter would be 66 centimeters. And remember, the perimeter is just the distance around the triangle. So you're just adding up all of those sides. All right, example 5. Find the perimeter of this quadrilateral. Well, this is a little bit different, right? Because the segments they give me are the entire side length, right? So if I look here, though, it's still dealing with the idea that these tangents intersect outside, making these segments congruent, okay? Now, with that in mind, how can I find some of these? Well, I can find this segment here because I know this is 2.5, which makes this 2.5. And if this whole segment is 8, to find this piece, I'm going to do 8 minus 2.5, which is going to give me 5.5. Right away, if this is 5.5, this is 5.5. Now again, if this is 4, this piece is 4. Now to find this piece, right, I'm going to do 5.8 minus 4, which gives me 1.8. How can I find the perimeter now then? Well, if I look at it, this side is 6.5. This side we know is 8. This side now is going to be 5.5 plus 1.8. Oh, that's a 5, right? Which gives you, what is that, 7.3? And then this side is 5.8. So now the perimeter would just be the length of each side added up. So 8 plus 7.3 plus 5.8 plus 6.5. And when I add that together, I get a perimeter of 27.6 meters. Okay. Now, in example 6, assume that the lines that appear to be tangent are tangent. O is the center of the circle. Find the area of the triangle to the nearest tenth. Well, to find the area, I have to know right away that this radius and this tangent create a right angle, giving me a right triangle. So in order to find the area, I actually have to find the length of the radius. Okay? Well, if that's a right angle here, what can I use to find x? I can use Pythagorean theorem. But what's crazy about this, it's going to be x squared plus 15 squared equals the length of the hypotenuse is x plus 9, which means I have to square that. Now, it seems like it's going to be a chaotic problem, and I personally like reviewing this algebra. So, x squared plus 225 equals, when I square this, I'm going to multiply it out like such. X squared plus 9x plus 9x plus 81, which gives me x squared plus 18x plus 81. So that's what that simplifies to. So now what's nice about this is right away, when I go to set this equal to 0, the x squareds actually eliminate. So I'm really solving an easy equation at the end. Okay, so if I have 18x plus 81 equals 225, 225 minus 81 gives me 144. Divide by 18, and I get x equals 8. Now, if x is equal to 8, to find the area of a triangle, we use base times height divided by 2, and the legs of the right triangle are the base and height. So 8 times 15, all divided by 2, would give me 60 inches squared. Okay, so this tends to be an easy lesson for some people, but difficult for others. Try your best on it and let me know if you have any questions.